Good afternoon, everybody. So my name is Boton Kadas. In this presentation, I will try to give some introduction about the system we have in the background. You can see here, it's a small smart factory based on Pesto didactic components, and we have an internal project together with Peter Baroni's group. And the aim of the project is to connect the real factory here in the background with in the Virka environment. So you already seen a presentation about Virka, so you're familiar with this. I have only 2 slides about this. So regarding the system itself, we call it SmartFactory, and it was installed and it's still the very last stage of the installation in our lab last year, and we will finish it in the next quarter. And the internal project is running, connecting the modules and the system components into the virtual reality and on the first floor of the institute. So it's almost completed. It is based on a Hungarian national project support. We have also in this project all the digital factory solution tools, including the robot, human material flow simulation from the Siemens environment. So the full setup will be completed in the next quarter, as I mentioned. Regarding the system itself, so I have pictured that maybe the camera, you can also see from the camera, it's in a functioning phase. We have 4 similar manufacturing stations you can see on this figure. Each of which has some automated rotating tables. We can imitate milling, drilling operations on them. We have a product handling system also in each station, which is automatic. And for internal storage, we have a warehouse, an automatic storage and retrieval system. This is full also automatically customized for our products, and also passing to the small robots. We have 2 robots. Initially you can see 3 in the figure, but only 2 are fitting in the room. These are autonomous robotinos, also by Pesto, and these are because of the speed, these are the bottlenecks in the system anyway. Maybe in the future we will have also some robots or manipulators for the products or some conveyor system. So this is the structure. So you can also see a picture about the system from an overview during the installation stage. And also we not in the Virka, but we already have some parts of the system modeled in 3D. So this will be an input for the cave system in the Virka. Something about the software background. We also have some off-the-shelf software solution for our solutions and our tools. For system modeling and IT system development, we have the Enterprise Architect, we have all the optimizer, cutting-edge optimizers, iLog and Express. We also use Mathematica, Wolfram. This is also used. Regarding the 3D visualization, we have all the results and mentioned from the Siemens PLM. On the other hand, some of the tools were also some overlaps with our own developed software solution. But for customers' purposes, we have the optimized scheduling systems. We are now working on a Milton optimizer. We also have our own distributed simulation tool. So also the running research and development activities are related to the software itself. So in these slides we have some videos which can take longer. Some of them are based on off-the-shelf solutions, and some of them developed by us. These are totally the same functionality for capacity-based analysis in manufacturing system and also in logistical system. The previous was based on Siemens plant simulation. This one is our own developed solution, of course with bigger problem sizes, but with less animation inside. Regarding the meal planner activity, so let's click on it. We are just developing a software tool for internal logistic optimization. This is less 3D we have the demands, we have the stations in which you can select different groups in which these different mill connectivities or internal logistics material service activities should be for this just under development. So I am showing these tools because the aim of our activity with the SmartFactory is to develop and demonstrate the running application on the system itself. So you can set different vehicles, different stations, and you can have an optimized solution for logistics. From the 3D simulation point of view, also we have off-the-shelf solutions we are using in our research activities. Some of them from Siemens, and we also have own developed solution with specific tools. This is done in Wolfram Mathematica, specific mechanism design. This is an example for bar beer machine with cylinders. Especially we are focusing here on the design of the mechanism. Also another option for complex synthesis of different mechanisms together, like an animal with 4 legs, for example. Also, if we go further in the direction of manufacturing, the implementation of 5-axis processor, for example, this is also done together in 3D in these tools. Parallel modeling of kinematics as well. So these are all developed by our colleagues in the lab. And if you go further and further regarding the freedom axis, so you can also have biomechanics, robotics. If we are turning back to this SmartFactory. So the goal of the SmartFactory here in our lab is to support the research and development activities, demonstrating existing and future results, and coupling the virtual and the real world. This is the main project we are working together with Peter Barney's group, and also we will focus on developing learning modules for small teams, especially focusing on industrials and also PhD students as well. So that's the project is going on. So just as a first steps from our development, which was done in the past few weeks, we have started to implement the SmartFactory interface, which is done in 3 steps. We have colleagues working on this library. Conversion in 3 steps means that converting the geometry into specific textures, extracting the kinematic graph from it, and we can later on automatically generate the C++ code. So this is visualized in the very last figure of my presentation. So we have if we have on the left bottom side, you can see the 3D part. With our application, we can get all the kinematics information, and with this you can generate the code in C++, which is automatically via the cyber devices and the connected data necessary sources. So this is the very first step in trying to integrate the demonstration models from the SmartFactory into the virtual laboratory. Thank you for your attention.
So I believe that we all understood that you have a grid environment in order to simulate some mechanism and some workshop with your facility. You just showed last slide the loop in order to connect it with IRCA. I wonder if this code generation with this process could be looped. But I mean that as it is shown here, you can integrate kinematics within a Virka cell, but there is no interaction from Virka into the designer system.
Yes, this will be the second part of our project, in which we will have sensors in Virka, and also, as you saw in the demonstration from Peter, that we will, the main idea is to extend the real part of the factory with some virtual part, with very expensive machines, for example, and combine them together, and in the cave, inside the Virka environment, we will be able to make the layout, including also the virtual objects and the virtual part of the factory, and simulate everything together as a cyber physical system, also in the reality, part of it in reality and part of it in the virtual environment. So yes, you are right. Currently in this solution, we just would like to make some automatized algorithms and solution to be able to include our three-dimensional models in the Virka environment. And in the second phase, this is a 2 years project, we will have a second stage in the project in which we will have the opposite direction as well. And also it is important to underline the control. So we would like to use only one specific control, which is also involved in the real part of the environment, and also in the cyber part of the environment. This will be also in the second stage of our internet project.
That means that your simulation tool is almost in real time, can be in real time, but
yes.
Can you rebuild the generation of code, the code generation and the visualization process? Will it be necessary to reproduce these code generations when the sensor will send new information or not?
This is currently what you see here is for the design phase. So the control and the real-time phase is not included in this figure, but that should be also, it's close to real-time, let's say. I would say like this. This is only for modeling our system inside Virka, and the control itself in the second layer still under development or design.